110. It was specified in the drawing that was provided for the screw. So this blade goes into the pocket, and this set screw basically comes right here. It jams itself in there, and the screw itself is slightly oversized, a couple of thou, not much. That's why I say when you tighten the screw, just touch it up a little bit. You don't have to torque it. Don't torque it. Matter of fact, don't torque it down. So that's how it works. It's not holding by a lot, but it works. Trust me, it's really solid. So I know that these utility blades are supposed to be fast to replace the blade, but again, I just don't like that feeling of loose blade. See, this is solid. This is super solid. Love that. Love that. See, almost zero gap. So the next design, I was supposed to incorporate into this one, but I didn't feel like bothering with it just yet. But like I was saying, utility blades, they like to make it very, very easy to replace the blade very fast. So this being a set screw in here, it's kind of hard for somebody to carry a set screw, especially not a set screw, sorry, an Allen key, especially one that's this small, so the next one will have a custom machined Allen key. On the back of the blade, I am going to machine a pocket on the scale. And I'm going to epoxy a couple of magnets on there, Neo magnets, probably the ones that I use for the failed prototype number 1. And I am going to machine a custom wrench that will sit this into the frame. And I'll also have magnets on here because this is going to be made out of titanium also. So titanium is non-magnetic, so you can't just slap magnets on here and call it a day. So I need to machine a groove or machine a profile, design a Allen key, and design a pocket to fit this Allen key, and also add a couple of magnets all over so it'll stay in there, and it stays in there good. So I need to see what type of room I have to work with, and yeah, so I have different ideas on how to solve different problems. Just needs time. I need time to do this because I have a 9 to 5. I have a 9 to 5, and I don't have all the time in the world to work on this like John Grimsmo and Tactical Keychain and NYC CNC. This is what they do, 9 to 5. This is my part-time, after work, after my 9 to 5 job. This is when I do it. So I like it. I mean, I'm really starting to like this. Again, this is the first knife design I've ever done. Usually I'm all about car parts. Car parts. But I like this. All right. I think that's enough ranting. Oh, wait. Fixtures. Look at that. I say a couple of weeks ago. Right now it's, what's today's date? Today is right before Thanksgiving. Look at that. Right before Thanksgiving, and it's cold. It's cold out there now. But when I was working on this a couple of weeks ago, it's got to be at least 3 or 4 weeks ago, maybe even longer. This fixture worked perfectly fine with some epoxy, with some glue, super glue. All I did was clean off the surface of the material, clean off the surface of this fixture. I glued it on there, I clamped it for a couple of minutes, and then I let the machine run, and it would be perfectly fine. I would come out with a perfectly good part. But since it's been getting cold, these have not been working. So this is very temperature sensitive. So my fixtures for the blade at the top guard, this was used using glue method. The frame was using glue method, and the latch was also a glue method. All these worked when it's warm outside. And the garage gets a little cold, so it gets quite cold actually. So this doesn't work anymore during the winter. So this whole gluing process out the door. So these 3 fixtures will never get used again. So new fixture, bam. Look how awesome that is. Whole lot of bolts to put that in there. So bolts holding onto the plate, to the parts instead of glue. Awesome. It worked perfect. Works perfect. A little more time consuming, but it works. That's what matters. Don't ask me why these are so thick for such a small part. These are the jaws for the latch, machining the second operation. Bam, just like that. Oh, so much reflection. Oh, look, you see that? My shell mill leaves a mirror finish. So this is what it is for the second operation, for the latch. So I face it off, and I mill a pocket in there. Very time consuming because it's so small. Again, I use a 2mm end mill for this, and it's going 1/4 inch deep. So that takes a while. I really wonder how long it's gonna take if this is titanium, because aluminum I'm ripping in about, I think 8 inches or so, full depth, 1/4 inch depth with a 2mm end mill. That's pretty deep for a 2mm end mill. That's 80 thou. That's over 3 times length. Only the machinist gurus or nerds would know what I'm talking about. But yeah, 3 times the length. 2 mil, 1/4 inch deep. In titanium. Or it's gonna be in titanium. I wonder how that's gonna do. We'll see, whatever. That's one fixture. These are for the second operation here. Bam, there we go. That's how it goes. Ow, that hurt. So that fits in there real nice. That fits in there real nice. 2 parts per, yeah, that's okay. 2 parts per. You get the idea. You get the idea. Come on, you get the idea. As I posted on Instagram, this chamfer here is not done by a chamfer tool. I actually used a 1/8 ball mill to cut that. It came out so nice, and I think I have so much better control over the surface finish, because I've always found that the chamfer tools leave a fairly nasty finish, and you need to dwell those things in order to have a decent finish. And you can't dwell in titanium, so not that this piece is titanium, but the next piece will be, or the finished product will be in titanium. So ball mill takes a couple of minutes, takes 2 to 3 minutes, I believe, to do one chamfer. maybe 2 minutes to do one chamfer. That's fine though. That's a nice finish. That's a really nice finish. Alright, whatever. Rambling. And this is for the, obviously for the frame. So, speaking of which, see, all my jaws have a step in it. I machined my jaws. My first operation is always to machine the jaws. So let's say this was my 5-inch vise. Let's say this was stationary, and then there's a movable jaw up here somewhere. Let's say this box. This is the removable jaw here. Whoops. This is the back jaw. All right. What I did was, with my vise, I only have one for now. I mic'd this width. And I machined this slot to fit in there perfect. So there's no side to side play. So I can always put this back and bolt it on without having to re-pick up my zeros, and it will always stay in the same exact position as long as I don't move the vise or the machine doesn't lose its position. What I have seen in the past is people using dowel pins here, and here, and also on the front jaw, you know, 2 more dowel pins, so they'll match. But the problem with that is, you know, you can only open it so much. You can only open this so much, and you still gotta tighten those screws in there. Remember, you still gotta tighten those screws in there. This way, I machine this. It locks in perfect. I can leave it alone. I can put my screws in, and that's it. And the front jaw can be wherever I want, you know, wherever, all the way open. That's the easiest way. And my back jaw measures right at 5 inches 002 width.